Okay, welcome back. This is 7.6, solving rational equations. And, it's just, again, this word rational has that word ratio in it. So what are we talking about? We're talking about fractions, okay? And it's not just fractions with, the arithmetic type fractions like 5/3 and 2/5. Now we have variables in the denominators as well. So let's take a look. To solve a rational equation, we're going to clear out the denominators, okay? To clear out those denominators, we're going to multiply both sides of the equation by the LCD, the least common denominator. Okay, so in previous chapters, we learned how to find the LCD. Now you'll be looking and finding the LCD and then multiplying by the LCD. Okay. Okay, so let's take a look at number 2. We have x over 5 equals x over 6 plus 1. Okay. So you look at the fractions here in the equation, and we have, x over 5 is one of them, x over 6 is another, and then you kind of say to yourself, what's the LCD of these? It's the same thing as if you were trying to add them together. So you want, what we did before was to kind of factor these guys and then make the denominators look the same. So this 6 would be missing a 5. And then this 5 would be missing a 3 times 2. In other words, it's just missing the 6. Okay, so the LCD is going to be 30. Okay. You can simplify that process in your mind. I mean, there's always more than one way. Well, not always, but there's a lot of times there's more than one way to look at something. And in particular here, how do you want to look at it? Well, you want to find the smallest number possible that's divisible by 5 and 6. For example, 10 is divisible by 5, but not by 6. And then 15, it's divisible by 5, but not by 6. 18 is divisible by 6, but not by 5. All that good stuff, okay? Sorry, something in my computer is going weird. All right, so what would be the smallest number? Then you could think of bigger numbers, maybe 5 times 12, so that would be 60. 5 divides 60 and 6 divides 60, but it's not the smallest number. So you go through all kinds of guesses, but at the end of the day, you're going to end up with 30, hopefully. If you do pick something like 60 that's too big, it still works. It turns out that it'll still be okay. You just may have some bigger numbers to deal with. So anyways, we found 30, and now we want to multiply both sides of the equation by 30. Okay. So over here, you can think of this is 30 over 1, so 5 goes into 30 6 times, and you're just left with 6x. Over here you have to distribute. So on the first distribution, 6 will go in the 30 again. Well, 6 goes in the 35 times. It's not the same as this, but so you'll end up with 5 times x, and then plus 30 times 1 is just 30. Move the 5x to the other side, so we get x equals 30, and that's our solution. Okay, let's do another. Okay, so this time a number that's divisible by 4, 12, and 2. Well, 24 would work. Let's try for smaller, right? I think 12 would work. So actually 12 would be the LCD. If I want to add all three of these together, the common denominator I'd use would be 12. Okay? So that's what I'm going to multiply by. Over here, you can think of 12 the same as 12 over 1. So you would have 4 goes in the 12 3 times, and then 3 times 5 gives you 15x. On this side, 12 times x over 12 will just leave you with the x, minus x over 2, so 2 goes in the 12 6 times, and you're just left with 6x. We can simplify the right-hand side by combining like terms. So x minus 6x is minus 5x. And then I could divide both sides by minus 5. Okay. So over here I have negative 3x, and over here I'll have, well, I guess that was a bit of a silly operation, wasn't it? Let me take that back. Okay, so where was I? I have, I'm going to move in this direction, so I'm going to use an arrow. Note how when I move in this direction, I don't put another equal sign there, I just put an arrow. It's like, hey, go over here. Okay, so 15x equals minus 5x. And what I meant to do was to combine the x terms on one side. So it's easy to screw this up. You saw me just screw it up. So I'm going to add 5x to the other side. Okay, so 15x plus 5x is 20x. And then over here is 0. I want to isolate x, so you'll divide both sides by 20. So x equals 0 divided by 20 is just 0. I'm sorry about that. It's a lot on my mind today, I guess. Okay, so these are fairly straightforward. You've probably seen these before in 0965, maybe. Sorry, 0955. So the deal is these aren't truly in what we're after, right? The rational equations, we don't, you know, we want to have some variables in the denominator to deal with. That's really where we're headed. So the only real issue with these kind of problems that's a complicating factor is, you know, compared to what we were just doing, is you have to watch out for restrictions. Okay, so if you remember when we first started working with rational equations, or rational expressions, rather, we had to first list the restrictions even before we started simplifying. You know, it's different than what you would have done in arithmetic. You don't have to worry about restrictions. There's no variables. So, you know, all I have to say is remember to note any restrictions. And when you get your solution, you have to compare your solutions to the restrictions. It's kind of equivalent to checking your answer. It just cuts out the middleman. It just makes your life a little easier, because the equations can get kind of ugly. Okay. So anyways, let's go to the book this time and look at checkpoint 2. And they give us a nice rational equation, 5 all over 2x equals 17 over 18 minus 1 over 3x. Okay. So I need something that's divisible by x. So I'll need an x for my LCD. Over here, I'll just write it here. I need something that's divisible by 18. Is 18 divisible? Yeah. So if you use 18, I think that'll work, right? 2 goes in the 18, 3 goes in the 18, 18 goes in the 18. So I believe our LCD is 18x. Okay, so I'm going to multiply both sides by 18x. On the left-hand side, the x's will cancel, and 2 goes into 18 9 times, and then 9 times 5 is 45. On the right-hand side, when I do my first distribution, the 18's will cancel, and I'll just be left with an x times the 17. So 17x minus Here the x's will cancel. 3 goes into 18 6 times, so 6 times 1 is 6. And then I have to solve for x. I'm going to move the constants to the other side. I'm going to flip-flop sides on the way. So 17x equals apparently 51. Divide both sides by 17. And I think I forgot to do exactly what I was setting out to do. Remember to note the restrictions. That should be your first step. Okay, so in the next problem, I better check that restriction first. 51 divided by 17, I believe, is 3. Okay, so what the heck was the restriction? I sort of went on about it, and then I just went in a different direction. To find the restrictions, you're taking the denominators and setting them equal to 0, and that will get the restrictions. It's basically the places where if you put in this number for x, you would have division by 0. So you're trying to avoid that. In other words, you want to make sure 2 times whatever x you put in there is not 0. And you could use this as an equation and solve for it. You say, okay, x better not be 0. Otherwise, when I put it in here, I'll have 5 divided by 0, which is bad. Likewise, for here, I better not have 3x ending up at 0. Okay? So if you divide both sides by 3, again, you see that our restriction, x can't be 0. 18 will never be 0, so I don't have to worry about that. There's no variable here, nothing to put in. This guy is in the clear. At the end, you have to check this with your restrictions. Obviously, 3 is not the same as 0, so it turns out that this guy is a nice solution, and we can go on with our day. Let's look at 14. So I have 7 all over x plus 1 equals 5 all over x minus 3. Okay, so this time I'm going to follow the procedure that's been outlined to me as a student. You want to take the denominators and set them equal to 0 and find the restrictions. Okay, so we can't have x plus 1 equaling 0. So in other words, we can't have x equaling -1. I can't have x minus 3 equaling 0. So in other words, I can't have x equaling 3. Okay, so now I just sort of throw that to the side and solve my equation. And if any of the answers are -1 or 3, I have to throw those out. Okay, so let's go at it. Some of you may say, hey, I can just cross multiply. Let's do what the book is having us do. So get practice that way. You know, a lot of math is just practice. So what do I need to do? I need to multiply by the LCD. I need to multiply by something that's divisible by x plus 1. And certainly x plus 1 is divisible by that. I also need to multiply by something divisible by x minus 3. So certainly x minus 3 does just that. Okay, so I'll have that times 7 over x plus 1 equals 5 all over x minus 3 times x plus 1 times x minus 3. If you wish, you can multiply it all out. I usually just do these in my head, but I'll show you because you've probably not been doing them very often. If you multiply this out, and what do we get? Well, we have 7 times x plus 1 times x minus 3 all over x plus 1, like that. On the other side, you have 5 times x plus 1 times x minus 3 all over x minus 3. Looks like that. And then you see that the fractions simplify, right? So this divides into that, leaving me with just the 7 times x minus 3 over 1, which is just 7 times x minus 3. On the right-hand side, the x minus 3's divide out, and you're left with 5 times x plus 1. Okay, so from that point, you want to simplify both sides, so I need to distribute. So I have 7x minus 21. On the right-hand side, I'll have 5x plus 5. Collect all the variables on one side, Get all the constants on the other. Divide both sides by 2. I'm going to move to the right, so I'm using my arrow. Don't use another equal sign. And you have x equals 13. Okay. So I think that's my solution. You always have to now basically check your answer. In the old days, we would just put this into our original equation and make sure it worked. With the restriction checking, you don't have to do that. It's a little quicker. You just have to make sure it's not 0, or sorry, it's not -1 and it's not 3, which in this case is definitely not. It's 13. So this will be our answer, and we can move on. So let's move on. Number 22. We have x plus 3 over x equals 19 over x. Okay. So I'm going to want to multiply through by x. Okay. Whoops, I forgot to get my restriction. I'm sorry. I'll get that here in a second. 19 over x. Okay, we need to make sure that the denominators don't end up being 0, and that happens exactly when x is 0. Okay, so our only restriction this time is just that x can't be 0. Okay, so anyways, I'm multiplying both sides by x. Over here I have to distribute, so I'll have x times x is x squared, plus, and then if you'd like, you could think of it as x times 3, 3x, all over 1 times x, x, 3x over x, but that will just simplify. The x's will divide out, and you'll have 3. On the right-hand side, if you were to multiply that out, what would you get? You would have 19 all over 19x over x, and then the x's would cancel out. So you'd just be left with 19 over 1, but that's just 19. So that's kind of what I'm doing. If you're not catching on to kind of what I'm doing, I'm bypassing this step right here and this step right here. I'm saying, look, automatically I can see it. There's no reason to, kind of extend the fraction bar and then write it like this. I can just say, hey, these guys will divide out, and by the time this side, these guys will divide out. You get 1 there, 1 over 1. So it'll be 19 over 1, which is this, and then 19 divided by 1 is just 19. Okay, this guy is a quadratic equation. So I want to set it equal to 0. It has that form, that standard form we want. We need to get it equal to 0. Okay, so I'm going to minus 19 on both sides. Then you get x squared minus 16 is 0. That's a difference of squares, so we can factor that into x plus 4 times x minus 4 equals 0. I'll take it apart. So x plus 4 is 0. In other words, x is negative 4. And then x minus 4 is 0, so x is positive 4. Okay. So it looks like we have two solutions. You check your restriction. It's x can't, the only thing x can't be is 0. So these guys are good answers. So one or the other will work in that equation. Okay, so we've seen a lot of, we haven't seen the restriction in action yet. So let's look at one where the restriction does affect the answer. So this will be 32. So we have 2 all over y minus 2 equals y all over y minus 2 minus 2. So the LCD, well, let's get the restriction first, right? So you have to take the denominator and set it equal to 0. We can't have this y minus 2 equaling 0, or this one. So the thing that would cause that would be 2. So we know y can't be 2. Okay, then I need to multiply both sides by the LCD of the fractions. So the LCD of these, well, it already has a common denominator. It's just y minus 2. So that's the thing I'm going to use. Y minus 2 times 2 over y minus 2 equals y over y minus 2 times y minus 2. These guys will divide out, so goodbye, goodbye. You'll just be left with the 2. On this side, when you multiply this times this, the y minus 2's will cancel, and you'll just be left with y. When I go this times this, it'll be minus 2 times y minus 2. So I need to clean this up. It's 2 equals y, distribute again. So minus 2y plus 4. Simplify. So y minus 2y is minus y plus 4. I'm going to add this y to this side. So I have y plus 2 is 4. And then finally subtract 2 from both sides, and I got it. Okay, so if you had not checked the restriction, you would have thought, oh, that's my solution, I'm going to circle it and go on. It turns out it won't work. Okay? This is the only possible solution that we found, but it doesn't work, therefore there are no solutions. So at the end of the day, because of this restriction, we can't include this as an answer. It's not in the solution set. In fact, there's nothing in there. So you'll write something like no solution. Okay? In your online work, they may have an option for you just to write that. And that just means that it's a set with nothing in it. They call it the null set. Okay? Okay. Let's look at another guy. So this will be 42. And we have 1 all over x plus 4. I just wrote 2, I meant 4. And then plus 1 all over x minus 4, and that equals 22 all over x squared minus 16. So I'm going to go after my restrictions. I need to make sure this is not 0, this is not 0, and this is not 0. I'll work with the most complicated part, the x squared minus 16, and set that equal to 0. And solve that. Okay, so it's a difference of squares. Then we have x minus 4 is 0. X plus 4 is 0. So we have two restrictions, 4 and negative 4, from that denominator. And so I look at these other guys, I'm kind of thinking, well, hey, this is going to have the restriction of 4. This will have the restriction of negative 4. Well, I already got them. Okay, so that just means I'm done. I got all my work done. So put it in a little box. So now we need to find the common denominator between these three. So if this is x plus 4, x minus 4, I think that's going to be our common denominator, right? So if I wanted to make these look like this, I just have to multiply top and bottom of this guy by x plus 4, top and bottom of this guy by x minus 4. So yeah, our common denominator would be x plus 4 times x minus 4. I need to multiply both sides by that. I rewrite this denominator over here just so it's blatantly obvious what's going on. So here in my distributions, I would have x plus 4, x minus 4 over x plus 4. And the x plus 4s would cancel, just leaving me with x minus 4. In this case, the x minus 4s would cancel, just leaving me with the x plus 4. on the right-hand side, the x plus 4's cancel and the x minus 4's cancel. So this and this completely go away. I'm just left with 22 over 1, which of course is 22. Combine like terms, so x and x is 2x. 4 minus 4 is 0. And on the other side, I have 22. Finally, divide both sides by 2. And it looks like I have x equals 11. Compare that to your restrictions. Okay, it passes. So therefore, this is our solution. Okay, let's look at some literal equations. Literal. So these are equations that have a bunch of variables in them. You're going to see them in your biology class and physics class, chemistry class, and they'll want you to solve for a particular variable and use it as a formula. Okay, so they want us to handle teaching you this stuff. And we'll start you out easy just with an example, an equation that hopefully a lot of you have seen before. Well, maybe not. F equals ma. Force equals mass times acceleration. We want to solve for acceleration. Okay, this is a physics formula. If you become an engineer, I hear you beat this formula to death. I'm going to isolate A. So it's as though this is a 3 and this is a 2 and this is an x, and you got to solve for x. The only real difference is you're not going to be able to simplify like we did with numbers, right? I'll have to divide both sides by m, and then on the left-hand side you can't simplify f over m. You just have to leave it the way it is. And that's really the only difference. Okay? Maybe before, maybe I would have had something like 9 equals 3x, and then I would divide both sides by 3. So x would equal 9 divided by 3 is 3. So the big difference is, you can't do that. You can't simplify like we did before. And that's really the only thing. And it can be quite annoying because you'll have these really ugly, complicated expressions, and it's like, ugh, I wish we could simplify, but you can't. Lastly, when you have equations like this in English, we like to read from left to right. So you're not going to put the variable you're solving for on the right. Okay? It'd be like writing a sentence backwards. You want to put the a on the left-hand side, and then you have a equals f over m. And that would be your formula. And you would use it in your lab or wherever they expect you to use it. And, that's the deal. That's what we want to do. Okay. So let's look at some harder ones. So for instance, example 8 in the book, and I believe this one is from optics. So maybe if you become a optometrist, you would be interested in this, making lenses, telescopes. I don't know where they're making lenses anymore, but something like that. I want to solve for the variable p. That's my funny looking q. Sometimes you have so many p's and q's, it helps if you put a little line like right through it, keep them separate. So that's my q. Right, so the first thing I want to do, I know that there's a bunch, this is kind of like a rational equation again, right? So I'm going to multiply through by something that's divisible by p, q, and f. And what is that? Well, it's just p, q, and f, right? So p, q, f. So I'm going to multiply, and there's no need to do restrictions for these problems. On the left-hand side, when this times this, the p's will cancel, leaving you with q times f times 1, which is just qf. When I go this times this, the q's will cancel that time, just leaving me with pf. On the right-hand side, the f's will cancel, just leaving me with pq times 1, but that's just pq. Okay. I want to solve for P, so that means getting all the P material on one side and everything else on the other. So you can subtract the PF. And again, you have an issue where you can't combine these. You know, it's not like this is 3 and this is 5, and you just go 3 plus 5 is 8. No, you can't do that here. Okay, it seems now it's like, oh, what do I do? I can't get P by itself. Well, you can actually factor it out of both of these terms. The GCF in this case is P, so you can factor a P out, and you have Q minus F. And then finally, you can divide both sides by Q minus F, and you're pretty much there. Okay. So this will divide by this. I want to write P on the left. Okay, so I'm going to switch sides here for a second. And then I have all this stuff over here, so it would be QF all over Q minus F. And nothing divides out here. No, this thing is kind of a thing unto itself. There's no Q minus F up here, so you can't mess with anything. Okay? There's no factor of Q down here. There's no factor of F down here. So it is what it is. Okay? It's like I was saying before, they can be kind of ugly looking, but it is what it is. Let's try number 54. So I have another equation from physics. The force, I forget what that was, just like something like the force between two objects is equal to gravity times the mass of this one times the mass of this one divided by the distance they are from each other. Okay. We want to solve for M2. So one thing you'll note in these equations that capitals matter. Okay, so big F is different than little f. And then these lower subscripts are important too. So M sub 1 is how they would say that, and this would be M sub 2. Okay. We want to solve for M sub 2. I usually just say M2 though, right? It's a little easier to say it that way. So first I'm going to get rid of the denominator on both sides. Okay, so I'm going to multiply both sides by d squared. Okay, so I'll have d squared times f equals big G m1 m2. And then I'm going to get m2 all by itself by dividing both sides by gm1. So finally, these would cancel out, and just leaving me with m2 on the right. And let me put that on the left so it's readable. So m2 equals d squared f all over gm1. Okay, that's about it. I think that's all I need to go over. We'll see you next time.